been using a lot of our special right triangles. They're not going away anytime soon. What we're going to do is we're going to use those special right triangles and we're going to apply them to our obtuse angles. Okay? Our non-acute angles within our rotation. We're going to use those through what we call reference angles. Okay? And then the reference angles will allow us to use our special right triangles to find the trigonometric functions for non-acute angles. Because right now all we can do is find the function values for 30 degrees, 40 degrees, or no, sorry, not 40, 5, 60, and then anything that is on an axis, 90 degrees, 180, and so on. So we can expand that repertoire through the use of reference angles. Okay? A reference angle is the positive acute angle made when we reference theta to the x-axis. And that part is very, very important. The x-axis. So we're relating theta to either 180 degrees or to 360. Those are the two measures of rotation x-axis. And so our reference angle, listed as theta prime, will be whatever that distance is from the x-axis to our angle of rotation, to that terminal side on our angle of rotation. Okay? So we're referencing it to the x-axis. Now, you'll notice on here quadrant 1 is not listed. That's because any angle in quadrant 1 will be its own reference angle. So if I have an angle of rotation of, say, 50 degrees, well, I know that that is 50 degrees from the x-axis. In quadrant 1 is its own reference angle. Once we move past quadrant 1, that's when we need to use our reference angles in order to get our trigonometric function values. So again, very, very important that reference angle is always found in reference to the x-axis. Okay? Not the y-axis, the x-axis. When we're drawing triangles, we always draw it to the x-axis. Okay? So it's always in reference to the x-axis. So first thing we'll do is we'll practice finding reference angles. And then later on, when we're finding reference angles and we're using them to find trigonometric function values, we're going to be finding some common values over and over and over and over. There's going to be a lot of repetition. Okay? So first thing we want to do is identify what quadrant we're in. 218 degrees is found in quadrant 3, past 180 degrees, but before 270 degrees. We're in quadrant 3. Okay? And so we have to look and see, okay, well, I've got my angle of rotation, 218 degrees. I need to reference it to the x-axis and identify, well, how much further did I go past 180 degrees? How do I find that distance? Subtract theta from the x-axis angle of 180 degrees. 218 minus 180 gives me how much? So our reference angle is 38 degrees. Theta prime, our reference angle, is 38 degrees. We rotated 38 degrees past the x-axis. Okay? Where this comes into play, and we'll see more later on, is that some of our trigonometric function values, like tangent of 218 degrees, is actually equivalent to tangent of 38 degrees. They'll be the same value. Sine and cosine will be very similar. They won't be exactly the same, but they're going to be very, very similar. So if I knew what tangent of 38 degrees was, I actually also know what tangent of 218 is because of that relationship with the reference angle. So that's where this comes into play. Now, over here, we've got a pretty large angle, 1,387. Well, I need to figure out what quadrant it's in. So I have to get it as an angle that's between 0 and 360. I need to get a coterminal angle and take that angle and get it in the standard position. it again. We're going to subtract 360 over and over and over until we get our angle in standard position. So if I subtract 360 once, what do I get? Okay, I need to keep going, so let's do it again. Say again. We need to do it again. What do we get? So now we have an angle in standard position because it's between 0 and 360. Since our angle is greater than 270 but less than 360, we know it's going to be in quadrant 4. So now we need to reference it to the x-axis. The distance from our terminal side to the x-axis. How do we find that distance? Maybe about like half of that because you're 360 minus theta. So what's our reference angle? 53 degrees. Our reference angle is 53 degrees. So you'll notice that we're finding the difference. Yeah, it's the same one from last week. Yeah. I'll have to look to see that. What we're doing is we're taking the angle measure, theta, and we're finding the difference from theta and the x-axis. Subtraction. So we're either going to be taking 180 degrees and finding the difference between it and theta, or we're going to take 360 degrees and find the difference between it and theta to get our reference angles. And so that's what this chart kind of breaks down. In quadrant 1, we see theta and our reference angle are the same, okay? Because we're referencing it to 0 degrees. So however much rotation, that's our reference angle. When we move to quadrant 2, well, now we're comparing it to 180, but we're trying to find that leftover, so we need to subtract theta from 180 degrees. That subtraction switches when we move to quadrant 3. We subtract the extra 180 to find how much further we rotated, and then in quadrant 4, we're subtracting from 360 to find our reference angle. So now we're going to use our reference angles. We want to find the values of the trigonometric functions for 210 degrees. We're going to use our special right triangles, but our special right triangles only have a 30 degree, a 60 degree, and a 45 degree. 210 is not in that list. That's where the reference angle comes in. Okay, so 210 degrees is in quadrant 3, past 180, before 270. What is my reference angle going to be? The reference angle for 210. 210 minus 180. So this distance right here, our reference angle is 30 degrees. Okay? This is where our 30, 60, 90 triangle comes into play. What we're going to do is we're going to say that our radius is something nice and easy like 2. Because the radius is also the hypotenuse of a triangle. If we take a point on our line and connect it to our x-axis, we get our 90-degree angle, our radius being our hypotenuse. On our special right triangle, if our radius is 2, our hypotenuse is 2, then we can use our 30, 60, 90 relationship and just kind of rotate it to fit where our angle is. And so this is why this triangle becomes really, really important, because I can look at my special right triangle and say, okay, opposite the 30 degrees is what side length? 1. Now I'm in the coordinate grid, and so I'm going down to get to this point. So what is y actually going to be? -1. Opposite the 30 degrees is the side length 1. And since we're going down on the y-axis, our y value is -1. And then what angle or what side length is adjacent to my 30 degrees? A special right triangle. What's that side length going to be? but x is left on the x-axis, so what's the change? Negative. So our x is negative square root of 3. So if I wanted to find the measure of, or the value of any of my functions, I'm essentially using my special right triangle. Because I'm in quadrant 3, x and y, my opposite and adjacent side have changed to negative instead of positive. So given this information, now what we can do is take that special right triangle and we can evaluate all 6 of our trigonometric functions. Negative root 3, negative 1, and we have 2 for all of those values. So what 2 sides am I going to look at for 200 and for sine of 210 degrees? 2 sides do we use for sine? Hypotenuse, y over r. So we're looking at y over r. What's my y value? What's my r? That's sine of 210. If we look at our triangle, our reference angle, okay, our special right triangle, sine of 30 degrees on our special right triangle, opposite over hypotenuse, 1/2. Sine of 210 degrees, same number, different sign. It's negative because our y value is negative. So the reference angles have the same value. We're just switching the sign as we move around depending on whether x and y are positive or negative. What 2 sides are we going to look at for cosine? Over r. X over r. What's my x? 3. And if we look at the reference angle, our special right triangle, cosine of 30 is a positive root 3 over 2. Same value, different sign. Because now x is negative. The same values. You're going to see a lot of repetition because we only got 3 numbers to work with when we're dealing with 30 degrees or 60 degrees. Or any reference angle related to that. The only difference will be some of them will be positive. So what 2 sides do we look at for tangent? Y over x. What's my y value? What's my x value? Negative root 3. So we simplify, become positive, and then rationalize. We get root 3 over 3. Now because sine and cosine were negative, because x and y were both negative, tangent becomes positive. Double negative. Once we have sine, cosine, and tangent, cotangent, secant, and cosecant come pretty quickly. Which function are we going to use to find cotangent? Tangent. So we're going to write our reciprocal. Root 3 over. Which function is the reciprocal for secant? Cosine. So what's secant of 210 going to be? 2, 3. We'll simplify it and rationalize it. So negative 2 root 3 over 3. If cosine is negative, so is secant. If sine is negative, so is cosecant. Sine's not going to change. Looking at a different order for the ratios. So what's cosecant of 210 going to be? Negative 2. So we have our 6 trigonometric function values, all based off of our special right triangle. Which is why you need to know how to make it on your own or memorize the special right triangle. Now I'm going to give you a little bit of a hint. Those are the 3 numbers for the special right triangle, for the 30, 60, 90. Okay? So as long as you know those 3 numbers, memorizing the triangle isn't that bad. Draw your angles. Doesn't matter where you put them, 30, 60, 90, or you could have 60 up top, 30 on the bottom. Doesn't matter as long as you have your right angle. Okay? Opposite the right angle is what side? Hypotenuse. Hypotenuse has to be what? The largest. So of these numbers, the square root of 3, 1, and 2, what's the largest? 2. What is the square root of 3 approximately? 1.7. Square root of 3 is approximately 1.7. Clearly less than 2, right? So our hypotenuse has to be 2. Okay? The largest angle is opposite the largest side. 90 degrees is the largest angle, 2 is the largest side. Okay? The smallest angle will be opposite the smallest side. What's my smallest angle? 30. What's the smallest side length? 1. Opposite the 30 degrees has to be the smallest side. 1. And then the middle angle across from the middle length. So as long as you memorize those 3 numbers, you've got your 30, 60, 90 triangle. 1, 2, and okay. So there's our special right triangle. Similar idea with the 45, but 45 is a little easier. So our general process is get your angle in standard position. There we go. That's the word I was looking for. Get your angle in standard position. Find your reference angle. Then you can find your 6 trig values and then make sure the signs are correct. If you're on the left side of your y-axis, x should be negative, which means that tangent could be negative, which means that secant's going to be negative. If you go below the y-axis, anything that uses your y value, sine, cosecant, that's going to change sign as well. So we've got 2. We don't need to find all 6. We just need to find the 1. We just need cosine. So we need to make sure we know what quadrant we're in and then what reference triangle we're going to use. So I want to find the exact value of negative 240 degrees. How would I get that angle in standard position? Add 360. Negative 240 plus 360 gives me what? Say that one more time. 120 degrees. So in standard position, we have a 120 degree rotation. That means that we're going to reference our 180. What is our reference angle? What is the measure of our reference angle? 60. So our reference angle is 60 degrees. 120 plus 60, that gets me to the... So we can take our triangle and we can draw it from here. Go straight down. Well, my reference angle is 60. So my 60's down here, my 30's up here. So let's look at this bottom, this x-axis. What does the length of this side have to be if it's opposite the 30 degrees? Now we went left, so what change do we have to make? Negative 1. Opposite the 60 degrees has to be what? Square root. To make that negative or leave it positive? We're going up. Stays positive. Okay? Up on the y-axis, stays positive. Our radius, our hypotenuse is 2. What 2 sides do I need to look at for cosine? Adjacent and hypotenuse. So what is cosine of negative 240 degrees? Negative 1/2. And that's it. We just need the 1. So we need to make sure we're in the right spot. David, don't leave her hanging. We need to make sure we're in the right quadrant because the only difference is some of the numbers become negative. Some of them will stay positive. So we need to make sure the signs are right. But outside of that, you're only going to get a few answer options. Your answers will always be some combination of 1/2, root 3 over 2, square root of 3, root 3 over 3, root 2 over 2, 0, 1. Those are all the answer options you have for all of these. You just need to make sure you have the right sign. Our answer pool is very, very limited. Okay? So we want tangent of 675. We need to figure out what quadrant it is. So how do we get that in standard position? What's our angle in standard position going to be? So because that's between 270 and 360, we know that we are in quadrant 4. What's our reference angle going to be? 45 degrees. We got a reference angle of 45 degrees. That means we're going to have the 45, 45, 90 triangle. What are the lengths of the legs on our 45 special triangle? A nice little 1. Are any of them going to change signs based on our location? Which one? The y value. That'll be -1. What is the length of our hypotenuse? √2. What two sides do we want to look at for tangent? X, Y, or R? X and Y. So, tangent of 675 equals -1. Now these two have a diagram. You're not always going to be given a diagram. So I want you to get in the habit of figuring out what quadrant you're in. Draw your triangle to the x-axis. Find your reference angle. Okay? You'll have to create this on your own. The time investment. It really, really is. I've been doing this for a long time, and one of the biggest mistakes is you wrote it as positive, but it's supposed to be negative. You got the square root of 3 and the -1 switched in the wrong place because you didn't draw your reference triangle. I was actually just talking about this with the most common mistake is getting those values switched. Pre-calculus or calculus is just getting those values switched in the wrong spot because you didn't draw the reference triangle. It's worth the time investment to draw your reference triangle. So here we have two that we're not given the values, or we're not given a diagram. So we need to figure out what quadrant we're in. So we have to know what it is in standard position. What am I going to do to get 780 in standard position? 360. 780 minus 360 gives me what? Is that in standard position? So let's do it again. 420 minus 360. Is that in standard position? Yeah, what quadrant are we in? One. Which quadrant? So we got our first quadrant, 60 degrees. Okay? And since we're in quadrant 1, that's our reference angle. So we finish our triangle. Okay? The y value. What's that going to be? Opposite 60. √3. What's our x value going to be? 1. What's our radius? 2. What two sides do I need for cosine? The cosine of 780 equals 1/2. Let's get -405 degrees in standard position. What do we do? What does that give me? Is that in standard position? Nope. Let's do it again. What does that give me? Is that in standard position? What quadrant are we in? 4. What's our reference angle? What's our x value going to be? What's our y value going to be? What two sides do I need for tangent? If we look at our radius formula, once we square that negative, it's not negative anymore. Now it's positive. Okay, so we got our sides, thanks to Ava. Opposite over adjacent. So tangent is -1. Very, very, very repetitious in the numbers that we're using. It's just making sure the signs are correct. Take the time, draw the triangles. Okay? Questions, comments, concerns, queries, conundrums. So 315 degrees is in quadrant 4. In quadrant 4, so our reference angle is that 45 degrees going up, and then so the triangle. Okay.